Hello, I'm Brian Watrous of VMware Education. In this segment, we'll be discussing how to configure vNetwork distributed switches. We discussed standard virtual switches in a previous segment. As you can see on this particular slide, distributed virtual switches do everything that standard virtual switches do and a whole lot more. One of the things that distributed switches do that I'd like to focus on first in this particular segment is distributed virtual switches make the configuration of your virtual networking easier. To understand how distributed virtual switches make the administration of your networking easier, consider, if you will, the three hypothetical hosts that we have illustrated here. And I'll refer to these as the orange host, the blue host, and the green host. With standard virtual switches, if we wanted to set up an environment that allowed us to perform vMotion migrations, which is a topic we'll discuss in greater detail in a later segment, we would need to configure on each host a standard virtual switch. So on each of these hosts, we have a standard virtual switch called vSwitch2. And as you can see, we've added two uplinks, two physical NICs for each host. In this case, we did so to provide redundancy in case one physical NIC goes down. And to make things nice and consistent, we have arranged that each host has added both vMNIC 7 and vMNIC 8. Now, for technology such as vMotion migration to work, we need to ensure that we have additional consistency across the hosts. For instance, you can see on each of these standard virtual switches that we have a virtual machine port group called production, another virtual machine port group called DMZ, and to carry the vMotion traffic itself, we have a VM kernel port. Again, each of these exists on each of our three hosts. Now, in order for vMotion migration to be possible, those names, the labels, such as production and DMZ, for our virtual machine port groups must be identical across all three hosts. Now, with two hosts or three hosts, it's not that difficult to achieve that degree of consistency, but actually it is. If you look a little deeper, it's not just the labels that we must set consistently across the hosts. There are other things we must also set consistently, such as VLAN IDs, security policies, traffic shaping settings, and NIC teaming. As you can see in the slide now, there's quite a good degree of complexity hiding behind the scenes. While these newest entries I added to the top of the slide here are not absolutely required for the purposes of vMotion, from a pragmatic perspective, you really do need to get all these things set up identically across the hosts. So with just this simple three-node cluster of hosts, we already have a good degree of complexity. Imagine how complex this would be if we had 30 hosts or 300 hosts. Pretty quickly, configuring standard virtual switches can become a bit cumbersome. So VMware invented distributed virtual switches. And as you can see in this slide, distributed virtual switches are managed centrally by the vCenter server. As we want to add network connectivity to each host, we simply connect the host to the distributed virtual switch. And as we do so for each host, we specify which uplinks, which physical NICs we want each host to contribute to this distributed virtual switch. So here the orange host has added vMNICs 7 and 8, and we'll do the same thing with the blue host and the green host. At this point, behind the scenes, VMware creates hidden standard virtual switches on each of those hosts. Distributed virtual switches don't make standard virtual switches go away completely, but rather what distributed virtual switches do is make it possible to manage your networking from a centralized perspective from the vCenter server, but have all the complexities of actually configuring each host taken care of behind the scenes. At this point, if we create a virtual machine port group called production on the distributed virtual switch, VMware will automatically propagate that virtual machine port group out to each of the hosts. If we do the same thing again with the DMZ network that we discussed previously, VMware once again will automatically propagate those DMZ virtual machine port groups to each host. And recall all the complexity that's hiding behind the scenes. It's not simply a matter of setting the same labels, but getting all those settings, such as VLAN IDs, security settings, and so forth, set correctly. For virtual machine port groups, such as the VM kernel port group that we're going to use for our vMotion purposes, things work a little bit different, and it actually turns out it's good that it works a little different for VM kernel ports. Whereas with virtual machine port groups, you create those centrally at the distributed virtual switch level. With VM kernel ports, you still configure each of those on each individual host. And the reason why that's good is that provides you the capability of configuring each VM kernel port differently if you need to. So with VM kernel ports, we'll configure those on a per host basis, but those changes will be reflected at the vCenter level on the distributed virtual switch itself. Now, if you consider an environment that is perhaps a little bit different from one host to another, you might discover, for instance, in the lower right-hand corner that I've switched out VMNIC 8 for VMNIC 9 on that green host. Now, in an ideal environment, we would have all our VMNICs configured identically across the different hosts. VMware doesn't require that, but having the VMNICs configured identically makes our life easier as administrators. But consider, if you will, the following. It's possible, and oftentimes desirable, with distributed virtual switches, whether we're dealing with standard switches or distributed switches, it's desirable at times to be able to specify which VMNICs are active and which VMNICs are standby. And conceptually, what we'd like to be able to do at the distributed virtual switch level is to say that for each of these hosts, VMNIC 7 is active and VMNIC 8 is standby. But if you recall, down in that lower right-hand corner, on the green host, for whatever reason, we ended up with VMNIC 9 instead of VMNIC 8. So that simple rule that we were attempting to set in the upper left-hand corner won't work in this environment. Now, VMware could have addressed this issue by allowing you to create different rules for each host, but that violates the principles behind or the goals behind having a distributed virtual switch. We want to eliminate that complexity. So while we could have different rules for the orange host, the blue host, and the green host, we don't really want to go that route either. So what VMware did to address this issue is to introduce a concept of something called a DV uplink. And I'll go ahead and label for the orange host our 2 DV uplinks. You set the number of just DV uplinks at the level of the distributed virtual switch. So for instance, in this distributed virtual switch, I've specified we want to have 2 DV uplinks. What that allows us to do is to have each host contribute 2 VMNICs, 2 uplinks. So in a sense, you might think of the DV uplinks as being a bucket. Each host, as it joins the distributed virtual switch, is going to put one of its uplinks into DV uplink 1 and another VMNIC into DV uplink 2. So just as the orange host has done so, contributing VMNIC 7 for DV uplink 1 and VMNIC 8 for DV uplink 2, the blue host will do the same thing, but notice what happens with the green host. In the case of the green host contributes VMNIC 7 for DV uplink 1 and is able to contribute VMNIC 9. Even though it's a different number, it contributes VMNIC 9 into DV uplink 2. At this point, by introducing the concept of DV uplinks, we now have the simplicity that we want out of those rules. We can simply say that for all of the hosts, the active uplink is DV uplink 1, and the standby uplink is DV uplink 2. So again, we get the best of all worlds. We get the nice simplicity of the rule, plus each host can have a different configuration if need be. We'll now go into a demonstration of how to configure distributed virtual switches. In this demo, I'll illustrate how to create a distributed virtual switch. I'll begin by going into Home, Inventory, Networking. In the networking view, we can already see 2 virtual machine port groups that have been created previously. One's called Production, the other's called VM Network. These are virtual machine port groups that exist on a standard virtual switch. But I'm going to create a distributed virtual switch by right-clicking a data center and choosing New vSphere Distributed Switch. I'm first asked what type of vSphere distributed switch I want to create. I will go with the most up-to-date, version 5.0.0. I then can name the distributed virtual switch. I'm going to give it a fairly generic name. I'll call it VDS01. And as we described in the lecture a few moments ago, you can specify how many DV uplinks you want. Since I only have one VM NIC to make use of for this particular demo, I'm going to change this number to 1. And notice that the number of DV uplinks has adjusted accordingly. On the next screen, I'm given the opportunity to add my hosts right now during the actual creation of the distributed virtual switch. Now I'll add one of them so that you can see how to do so during the actual creation of the distributed virtual switch, and then after the switch exists we will show you how to create one after the fact. So I have selected the host that I want to add to the distributed virtual switch, ESXi01, and I'm going to have that host contribute VMNIC3. At this point, the interface illustrates for us the distributed virtual switch that we're about to create. It's going to have, by default, a virtual machine port group called DV port group. We can change that name. In fact, we will do so in a moment. And on the right side of the interface, you can see that the one VMNIC that particular host has contributed is VMNIC3. If I click Finish, a few moments later, I'll have a distributed virtual switch. And in fact, we can see that distributed virtual switch displayed over on the left side of the vSphere client. This item here is a virtual machine port group. This is the name that we saw previously. It is, however, just a default name. I'm going to change the name of this virtual machine port group to something that's more descriptive of what we'll be doing with this virtual machine port group. We're going to be connecting this virtual machine port group to our test dev network, so I'll name the virtual machine port group accordingly. But at this point, I have a distributed virtual switch called VDS01. This item here is a container for all our DV uplinks, and this is a virtual machine port group. Now to add the other host, ESXi01, I'll simply right-click the distributed virtual switch, then choose Add Host. At this point, I will see a list of all the other hosts that the vCenter server knows about. If I select host ESXi02 and its VMNIC3, then click Next, I'll see a summary of what's about to occur, and after clicking Next and Next, I'll see an illustration of what I'm about to do. I'm about to add host ESXi02 along with its VMNIC3 to the virtual switch called VDS01. And again, a few moments later, I have a distributed virtual switch which now has 2 hosts connected to it. You can actually see those hosts at any point in time by selecting the distributed virtual switch and clicking on the Host tab. Now that we've created our distributed virtual switch, if we want to connect a virtual machine to that distributed virtual switch, we can go to the VMs and Templates view, select the virtual machine that we want to connect to that distributed virtual switch, right-click that virtual machine and choose Edit Settings. If we then select the virtual machine's virtual NIC, as we did with a standard virtual switch, we can then go to the pull-down list of available networks and choose from the virtual machine port group that exists on the distributed virtual switch. So here's our virtual machine port group called TestDev, which resides on the distributed virtual switch called VDS01. If we click OK, the virtual machine a few moments later will be connected to that distributed virtual switch. And this concludes our demonstration for this segment. VMware Education Services offers training in over 500 training centers across the world in 60 different countries. We offer both direct training and training through our VMware Authorized Training Centers. We offer instructor-led training in both classroom and live online formats. We offer private on-sites and e-learning modules available online. To find out more information, please see us online at the URLs listed on the screen. Thank you.